Example 2 in sine function, we have fx equals to 1 plus sine 2x. So again, we will begin the step with finding the phase shift, which is the point where the cycle begins. So we have this case here, we have the 2x equals to 0. The content here, we make it equal 0. So as a result, we have x equals to 0, where we know the cycle of the graph is begin at x equals to 0. Follow, we find out what is the period, where we have 2 pi over modulus m, where the m here is corresponding to the coefficient of x here. So as a result, we have 2 pi over modulus 2 equals to pi, where one cycle of the sine graph will complete in the length of pi. Next, we would like to find out the subinterval width by using pi over 4, where this subinterval width is the width between the two x value that I have later in the construction of table. So by period dividing by 4, so I have answer pi over 4, and this is also the common difference of the x value in the table later. So go on. Next, we construct the table for one cycle, where we will begin with the x equals to 0 from the phase shift, followed by the next value. We add on with the common difference. I have pi over 4. Add on further pi over 2, further 3 pi over 4, and last pi. And then next, by using all this x value here, we calculate the corresponding function value, and I have the result as 1, 2, 1, 0, 1. And once this table is complete, now we can go for the graph sketching for the case of one cycle. So by the reference of the table now, I will first start with the x-axis, input all the x value I have in this table here as reference, and also insert the y-axis after this with the corresponding y value I need according to the table. Now, once this is ready, we start our plotting. The first pair, 0, 1. The second pair, we have it as pi over 4 and 2. Pi over 2, 1, 3 pi over 4, 0, pi 1. And then we connect the graph according to the shape of sine functions. So this is the shape of the graph that we have. And by right, the plotting, we would like to erase it. And there goes the answer for the graph sketching for one cycle. And similar like previous example, this is the graph of one cycle as a foundation for us to fulfill whatever domain that required by the questions. And if let's say the question asks for infinity to infinity, the coverage that we need to fulfill here will be the one that I show in the diagram here, highlighted in green. And in order to get the graph done completely, let us extend the x value that I have towards the right and towards the left. So towards the right, we will have it plus with the common difference pi over 4. Towards the left, we will have it minus pi over 4. So we add in the value accordingly. And next, we complete the cycle. And there goes the graph. So this is the graph infinity to infinity. Of course, if let's say I extend the x-axis further, the graph will continue extend infinitely lah. But the scale of the Cartesian plane, the axis coordinate that I have, is just this size here. That's why I just sketch until this form here. And next, what if the case that let's say we would like to have the x from 0 to 2 pi, which is 0 to 360 degrees. So what we're going to do is that again, we use the one cycle graph here as a foundation. Then let us identify where is the graph happen to stop, which is 2 pi. So we're going to extend the value of the x-axis by having the next value after pi. We add the common difference pi over 4. So we have 5 pi over 4, follow 3 pi over 2, still not yet reach 2 pi. So we extend further 7 pi over 4. And finally, we reach 2 pi. Just nice 2 pi. No overshot. So therefore, this is the regions that we need to have graph. And what we need to do is just extend the graph further accordingly to get the answer. So this is how we get the answer for the case of x from 0 until 2 pi.